Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we are going to be solving GMAT probability problems, and I will only pick up problems which are hard, like problems which you would expect to get if you are planning to achieve more than 700 on your GMAT, or if you're planning to achieve more than at least a 49 in your GMAT score, right? GMAT math. So let's go ahead and get started. So I have some collection of problems, and I think the collection is diverse enough so that you can actually see all different probability problems in these problem set. And apart from that, what I want to show you is that when you actually see a question, how do you actually tackle that question? So I haven't seen these questions for a long time. So what I'm going to be showing you is I'm going to be showing you how I approach these questions real time when I see them. Okay, so let's go ahead and get started, right? So the question says that a fair coin is flipped 3 times. So it's a coin question, right? What is the probability that the coin lands twice on head, exactly twice, right? So you need H, and T. Right? That's what you need. You'll need 2 heads and you need 1 tail. And again, it's very important to kind of write your expression in this format. That kind of helps you to kind of solve the question easily. In all the probability questions, you're supposed to kind of figure out what are the individual events that comprise my complex event. So this is over here is your complex event, and these over here are your individual events, right? So what is the probability of getting 2 heads and a tail? So that is equal to probability of a head into probability of a head into probability of a tail. Like, just so you know, I've shown in my probability videos that probability of a complex event which comprises of individual events is equal to the product of the probabilities of the individual events times its arrangement. Right, so I've shown that in the videos, and this is true for independent events, and GMAT as of now will only ask you independent events. It will not ask you events which are not independent. So in how many ways can HHT arrange itself, right? So HHT can arrange itself in 3 factorial by 2 factorial ways. Right? Why 3 factorial? Because there are 3 words, and why 2 factorial? Because there are 2 repetitive words. So 3 factorial divided by 2 factorial ways. These are the number of ways in which HHT can arrange itself, right? If you think about it, in how many ways can HHT arrange itself? It's HHT, HTH, and THH. These are the 3 ways, and which is equal to 3 factorial over 2 factorial, right? Which is 3 ways. So that's just a quicker way of finding out in how many ways can this complex event arrange itself. So the probability that the coin lands exactly twice is probability of HHT, and HHT can arrange itself in 3 factorial by 2 factorial ways, and these are the probabilities. Now the question is easy now. What is the probability of getting 1 head? Is half. What is the probability of getting another head? Is half. What is the probability of getting a tail? It's half times 3 factorial over 2 factorial, which is 3. Hence the answer is 3 by 8, which is our answer, option B. Right, so it took me time to explain this to you, but if I would have seen this question, it would have taken me 10 seconds. And the thing that you needed to know, so what was the takeaway from this question? So the takeaway from this question was that you need to know that the probability of a complex event is equal to probability of individual events that the complex event is comprised of times its arrangement. That's what you need to know, nothing else, right? And you need to figure out how do you arrange HHT, right? If you are not aware of some stuff that I'm doing here, please watch my probability videos. You will understand where am I coming from, right? So yeah, so I hope this was helpful. Let's move on to the next one. Okay, so let's look at this problem now. So this problem says that is the probability, it's a data sufficiency problem, just so you know. It's the probability that Patty will answer all the questions on her chemistry exam correctly greater than 50%. So again, we have a complex event. What is the complex event? The complex event, it comprises of individual events. that is individual questions. Question 1, question 2, question 3, and so on till question n, because we do not know how many questions are there in the exam. So the question is asking, what is the probability of answering all the questions correctly? Is that greater than 50%? Right? So we have a complex event. So what do we need to know for this complex event? We need to know the probability of solving the question 1 correctly into probability of solving question 2 correctly into probability of solving question 3 correctly, and so on till probability of solving question n correctly. So the question is asking, is that greater than 50%? Right? So that's what the question is. Now, that is if we know the individual probabilities, right? So of course there's going to be an arrangement parameter here, which I'm not concerned about that because there is a whole lot of information that I do not know about the question. So I'm going to stick to this statement here. This is what we need to know, right? Okay, let's see the first statement. It says that for each question, Patty has 90% chance of answering the problem. Right? So for each question on the exam, she has 90% chance. So that means probability of solving, of getting each question right. So if this is also 0.9, this is also 0.9, this is also 0.9, everything is 0.9. But what do you do not know? You do not know the value of n, right? What if n is 1? What if there's just one question in the exam? That will be good, right? So the probability, this complex probability turns out to be just probability of Q1, which is 0.9. Right? So in that case, this is greater than 0.5. That means the answer to this statement, that is the probability that Patty will answer all the questions correctly, is a yes. Right? So it's a yes-no data sufficiency problem. To tackle this problem, what do you need to get? You need to get a yes and you need to get a no. So if you're able to get either of these things, you can say that the statement is insufficient. So let's say if n is equal to 100, right? So if n is 100, then the whole complex probability becomes 0.9 raised to the power 100, which is definitely going to be less than 0.5, right? That means then the answer is a no, right? So that means this statement is insufficient. Let's move on to the second statement. So if statement 1 is insufficient, it's either answer option B, C, or E, right? So these are some scratch paper skills that you'll have to develop if you want to score highest on your GMAT math, right? So you need to develop these scratch paper skills. Writing down what is left, writing down everything cleanly. That's the way I'm doing. So the question is saying there are fewer than 10 questions on the exam. So that means n is less than 10. So if n is less than 10, we do not know the individual probabilities. That means this itself is insufficient. Hence B gets eliminated. Now, from both the statements, I have that the probability of solving each question is 0.9 and n is less than 10. Now, what do we need to do? We need to get a yes and we need to get a no. And as simple as that is, when n is 1, the probability is 0.9. In that case, that is greater than 0.5. So that's a yes, right? If n is 2, the probability is 0.9 into 0.9, which is 0.81. In that case, it's greater than 0.5. Fine. When n is 3, it's 0.9 into 0.9 into 0.9, so it's 0.729. If that is greater than 0.5, yes. Now you don't need to go any further. If you say n is equal to 4, you're likely going to get something like 0.6. If n is equal to 5, you're likely to get something like 0.5. If n is equal to 6, you're likely to get something like 0.4. So eventually it is going to drop by 0.5. So eventually you're going to get a no because n is big enough. Right? So in that case, you will get a yes, you will get a no. That means statement C is also insufficient. Hence E is my answer. So what did I do here? I just solved the question very easily here. I used the same expression that I used in the last question, that is the probability of a complex event is equal to the probability of individual events multiplied times its arrangement. There was no arrangement here because the question numbers were specified. Apart from that, The first question did not give any value of n, so it was insufficient. The second question said n is less than 10, it was insufficient. Together, n being less than 10 gives us very inconclusive evidence, so the statement E is my answer. Right? So remember, be organized, that's the key. So let's move on to the next one. Okay, so let's see this question here. Okay, so this question here says that there are 10 women and 3 men in a room. So there are 10 women and 3 men in a room. One person is picked at random from room A and moved to room B, right? So this is what room A has. So one person is picked from here and moved to room B, where there are already 3 women and 5 men, right? So that's what we have. We have 10 women and 3 men in room A. One person is picked from room A and moved to room B, where there are already 3 women and 5 men. Now, if a single person is to be picked from room B, what is the probability that a woman will be picked? So you have already picked up a person from here and you've moved it to that particular place. Now, is that going to change my final answer depending upon what do I pick from room A? Of course, it's going to change, right? If I choose a woman, then there are 4 women here. If I choose a man, then that means there are 6 men here. So that means this question has 2 cases. What are the 2 cases? The 2 cases are that if I pick a woman from room A, right? So from room A, if I pick a woman, then the room B has 4 women and 5 men. And if I pick a man from room A, then room B will have 3 women and 6 men. Right? That's the composition it's going to be. So I have a complex event which has 2 different cases here. So first of all, what's going to happen? First of all, I'm going to pick women from room A. So what is the probability of picking up a woman from room A times the probability of choosing a woman from room B plus the probability of picking up a man from room A times the probability of choosing a woman from room B. Like if you think about it, how did I come to this expression? If this is the probability of choosing a woman from room B, it actually comprises of 2 parts. One part is that you have picked up a woman from room A. Another part is that you've picked up a man from room A. And what you need to do is you just need to add these probabilities. And that's what we're doing here, right? So what I'm doing here is I'm kind of splitting the probability of picking up a woman from room B into 2 parts, and those 2 parts are different. You can see they give you different compositions here, which is why I have to add them, right? So what is the probability of choosing a woman from room A? That's 10 out of 13 times what is the probability of choosing a woman from room B when you have chosen a woman from room A. That is this case here. So choosing a woman is 4 out of 9 plus what is the probability of choosing a man from room A? That is 3 out of 13. And once you do that, what is the probability of choosing a woman? That is 3 out of 9. So that's your probability. So this is 40 over 117 plus 9 over 117. That means your answer is 49 over 117, which is your answer option B. Fine. So the key to this question was getting here. That was the key to the question. And of course, figuring out that there are 2 different cases. I think that would have been the easiest part, to figure out that there's going to be 2 different cases, but coming up with this expression that you're trying to bifurcate 2 probabilities into separate parts, right? So that was the key, right? So I hope you understood this, guys. Let's move on to the next one. Okay, so let's see this question. It says that if the probability of a rain on a given day in Chicago during the summer is 50%. So the probability that it will rain on a day is half, right? That's 50%. Independent of what happens on any other day. Of course, GMAT will always ask you independent events. What is the probability of having exactly 3 rainy days from July 4th to July 8th? So July 4th, 5th, 6th, 7th, and 8th. So you want 3 rainy days. So you want rain, 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 no rain, no rain. It is a complex event, right? You need to find out what is the probability of rain, 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 and no rain and no rain. Now, again, a complex event, given the events are independent, the probability is the probability of individual events, probability of rain into probability of rain into probability of rain, into probability of no rain into probability of no rain. But now here what happens is that the order here actually doesn't matter. You could have rain, rain, no rain, rain, and rain, and that would be counted as a different probability. So what do you have to do? You have to count for the arrangement of this, right? If you don't understand why am I doing this, you need to watch my probability video, that why I do this. Now, just a brief explanation of it is that here the order does not matter. I have specified R, 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 N, N. I have specified there's going to rain on the 4th day, rain on the 5th day, rain on the 6th day, not rain on the 7th day, not rain on the 8th day. But that is not what the question is asking. The question is asking you other probabilities as well. Raining on the 1st day, raining on the 2nd day, not raining on the 3rd day, raining on the 4th day, not raining on the 5th day, and so on. But since these probabilities are the same, what you can do is you can just multiply the probabilities by the number of times this could arrange itself. So how many ways can R, 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 N, N arrange itself? That is easy. That is 5 factorial divided by 3 factorial into 2 factorial. That is the number of ways this can arrange itself. Right? So that is what you have. You have the answer here. So probability of a rain is half times half times half times half times half. Because the probability of rain is half, then probability of no rain is 1 minus probability of rain, which is again half. Right? So you have half times half times half 5 times. So this is raised to the power 5 times 5 factorial over 3 factorial into 2 factorial. So that is 1 over 32 times 5 times 4 over 2. So I'm just making this 5 times 4. This is 2 times 2. This is 2 times 16. So the answer is 5 over 16. Hence the answer is option C. So again, you could see the same pattern is repeating itself. They give you a complex event and then they ask you to find out the probability of that complex event. And that complex event comprises of some individual events. And again, you need to count for the arrangement because the question does not specify any given arrangement. So you have to account for all different possibilities of arrangements, right? So yeah, so if you're not able to understand some parts of it where I am jumping some loops here because I am assuming that you know some stuff. So you have to watch the basic probability videos to actually understand some parts of it. But I hope this was helpful. Okay, so moving on to the next one. Okay, so let's see this problem. And I think we're starting to see a pattern here. So the question says, in a shipment of 20 cars, 3 are found to be defective. So you have 3 defective cars and you have 17 not defective cars, right? That's what you have. If 4 cars are selected at random, again, it's a probability of 4 events. What is the probability that exactly 1 is going to be defective? So you want 1 defective and 3 not defective. So what is the probability of this complex event? It's the multiplication of probability of individual events times the arrangement of it. So what is the arrangement of it? It's 4 factorial over 3 factorial. That is the number of ways this can arrange itself, right? So what is the probability of it being defective? That is 3 over 20. Probability of not defective, that is 17 over 19. Now why is that? Because once you've picked one car, you have already picked that car. You cannot re-pick that car. So you're only left with 19 cars now. And in the next one, you're left with 16 non-defective cars out of 18 cars. In the next one, you're left with 15 non-defective cars out of 17 cars. Times 4 factorial by 3 factorial, which is just 4. So what is happening here is you had 20 cars, you picked a defective car, the probability is 3 out of 20. Now you're left with 19 cars. Out of the 19 cars, how many are not defective? So that's 17. Then that goes on. So if you try to solve this, you see this 17 goes with 17, and then this 4 goes at this 5, and this 5 goes at this 3. Then this 3 times 3 is 9, so this goes at 2, and this 2 goes at 8. So it's a complex thing. So 8 over 19 is what you have. Hence answer option C is going to be my answer. So easy question. Again, it's asking the same thing, right? It gave you a complex event and it had some individual events with certain probabilities, and you had to account for its arrangement, and you had to solve this problem, right? Now you have to be very careful. Here the question did not specify any arrangement. So you have to account for DNNN, NDNN, NNND, right? So you have to account for N and DN. So you have to account for all these 4 different possible cases, which is why this 4 is here, right? So I hope this was helpful, guys. Let's move on to the next one. Okay, so let's see this problem here. So this problem says that a certain bag of gemstones is composed of 2/3 diamonds and 1/3 rubies. If the probability of randomly selecting 2 diamonds without replacement, now this is what it's doing, is it's kind of giving me reverse engine. This is a reverse question. It has given me probabilities and is asking me the number of stuff. So again, you know, the concept remains the same, but it just gets simple there. So again, one thing is, whenever the question asks you fractions, and you're supposed to find the number of something, right? So then you can obviously start with assuming you can start with assuming that, let's suppose that there were X diamonds or there were Y rubies, but there's a smarter way of doing that as well. Now let's go through the question here. The question says a bag of gemstones consists of 2/3 diamonds and 1/3 rubies. So you have a bag and it has 2/3 diamonds and it has 1/3 rubies, right? And if the probability of randomly selecting 2 diamonds from the bag without replacement is 5 by 12. So now let's say that the bag has 3x gemstones, okay? Now why am I using 3x? I could have used x, but I don't want to involve fractions in there, because whenever we see fractions we get confused. That's normal tendency, because we are very good with discrete numbers, right? Because we've been taught discrete numbers since our childhood. So what do? Is we assume that there are 3x gemstones. That automatically tells us that there are 2x diamonds and there are x rubies, right? So that is taken care of. Now what is the probability of selecting 2 diamonds from the bag? So what is the probability of selecting 2 diamonds from the bag? So now let's just apply that to this particular problem set we have. Now if you pick up 1 gemstone, what is the probability of 2 diamonds? That's probability of a diamond into probability of the next diamond times 1, because there's no arrangement here, because D and D can arrange itself in just one way. So probability of getting 2 diamonds is probability of a diamond into probability of the second diamond. Now what is the probability of getting the first diamond? The probability of getting the first diamond is 2x over 3x, right? Out of 3x gemstones, you have 2x diamonds, so the probability is 2x over 3x. Now, how many diamonds you have left now? Once you've picked up a diamond, you have 2x minus diamonds left, you have x rubies left, and you have 3x minus 1 gemstones left, right? So that's what it is. You picked up 1 diamond and you picked up 1 gemstone, so that means you don't have 1, you have everything left but 1. Now what is the probability of picking up the next diamond? So how many diamonds you have left now? 2x minus 1, And how many gems you have left now? That is 3x minus 1. That is given to be equal to 5 by 12. Right? So that makes stuff easy now. So you have x and you have x gone. So that is 2/3 of 2x minus 1 over 3x minus 1 equals 5 by 12. So this 3 goes there, makes it 4. This 2 goes there, makes it 8. So this 8 goes up, this goes up. So you have 8 times 2x minus 1 equals 5 times 3x minus 1. Then you have 16x minus 8. Then you have 15x minus 5. That means x is equal to 3. So what did we do here? This was just calculation, but here we had 2 diamonds, and that's a complex event. The probability of selecting 2 diamonds is probability of selecting the first diamond into probability of selecting the second diamond, because it is without replacement. So what is the probability of selecting the first diamond? It's 2x over 3x. And what is the probability of selecting the second diamond? It's 2x minus 1 over 3x minus 1, and that is given to us as 5 by 12. Now we have x equal to 3. So how many gemstones are there? There are 9 gemstones because 3x. How many diamonds are there? There are 6 diamonds and there are 3 rubies, right? So just substituted the value of x here. Now the question is asking, what is the probability of selecting 2 rubies? Simple as that. Probability of selecting the first ruby times probability of selecting the second ruby. So what is the probability of selecting the first ruby? That's 3 by 9. What is the probability of selecting the second ruby? 2 by 8, right? Because you have 2 rubies left out of 8 total gemstones. So this goes like this goes like this. So the answer is 1 by 12. So I hope you understood this problem, guys. And I hope this was easy. Again, it was similar things. We had complex events, and the question here asked us, the question was backwards, depending on all the previous other questions, right? So all other questions asked you a straightforward thing, but this question asked you something backward, right? So I hope you understood this, guys. So thank you very much for watching this video, right? I really appreciate it. For more videos, make sure that you visit our website. We have all our videos on the website, that is perfect-course.com. We have self-preparation courses. Now we have even live courses, so you can visit that out. Like our Facebook page, and for any feedback, please email me at this email address. You can also email me at support@perfectcourse.org. Right, so you can do that. Thank you very much for watching this video. I'll see you in the next one.